Yes, good morning.
Today, we're going to discuss about mass relationships in chemical reactions, which I know will be an interesting topic.
On our previous lesson, we defined stoichiometry as the study of the quantities of materials consumed and produced in a chemical reactions. It is a collective term for the quantitative relationship between masses, the number of moles, and the number of particles, such as ions, molecules, and atoms, of the reactants and products in a balanced chemical equation.
To further understand our topic for today, here is an example problem. So let's go to the lab and then solve it. Ammonia, or NH3, is a leading industrial chemical used in the production of agricultural fertilizers and synthetic fibers. It is produced by the reaction of nitrogen and hydrogen gases. It is represented by the equation 3H2 plus N2 yields to 2NH3. To know their ratio, look for the coefficient of each element or compound. In the given problem, the ratio of moles H2 to moles NH3 is 3:2, while the ratio of moles N2 to moles NH3 is 1:2. The first question is how many moles of NH3 will be produced if 10.4 moles of H2 reacts completely with N2? First, look for the given, 10.4 moles of H2. Then find the number of moles of NH3 by multiplying it to the ratio of NH3, which is 2 moles, over the ratio of H2, which is 3, to cancel it out. The answer is 6.93 moles of NH3.
How many moles of N2 or nitrogen gas are needed to produce 42.4 moles of NH3 or ammonia? In this, we are tasked to convert moles of NH3 or ammonia to moles of N2 or nitrogen gas. Given in this problem, we have 42.4 moles of NH3, and to find the number of moles of N2, we will multiply it to the ratio of N2, which is 1, over the ratio of NH3, which is 2, to cancel it out. The answer would be 21.2 moles of N2 or nitrogen gas. So for the next question, how many grams of NH3 or ammonia will be produced from 25.7 moles of N2 or nitrogen gas? In this question, we are tasked to convert the moles of N2 into moles of NH3 and to its grams. Since we are looking for grams, we will multiply first the given 25.7 moles of N2 to the ratio of NH3, which is 2, over the ratio of N2, which is 1. We will get an answer of 50.14 moles of NH3 because this unit will be cancelled out. Now that we got the number of moles of NH3, we will multiply it to the molar mass of NH3, which is 17.03 grams, over 1 mole of NH3. The answer would be 875 grams of NH3.
How many grams of NH3 will be produced if 122 grams of nitrogen gas reacts completely with hydrogen gas? First, we need to convert grams of N2 to moles of N2. We multiply the given 122 grams of N2 by 1 mole of N2 over its mass 28.02 grams of N2. Then, we convert it to moles of NH3 by multiplying it to the ratio of NH3 over the ratio of N2, which is 2 and 1 respectively. Then, to get the grams of NH3, we multiply it to 17.03 grams of NH3 over 1 mole of NH3. The answer is 148 grams of NH3. For the next problem, sodium lithium hydroxide is used to remove carbon dioxide and is called a carbon dioxide scrubber. This technique has been used for space vehicles. The reaction is 2 lithium hydroxide plus carbon dioxide yields lithium carbonate and plus water. The ratio of lithium hydroxide to carbon dioxide is 2:1. The question is, how many grams of carbon dioxide can be absorbed by 785 grams of lithium hydroxide? We get the mole first of lithium hydroxide by multiplying the given 785 grams of lithium hydroxide to 1 mole of lithium hydroxide over its mass 23.949 grams of lithium hydroxide. Then, we get the mole of carbon dioxide by multiplying it to the ratio of carbon dioxide over the ratio of lithium hydroxide, which is 1 and 2 respectively. Lastly, to get the grams of carbon dioxide, we multiply it to the mass of carbon dioxide, which is 44.01 grams over 1 mole of carbon dioxide. The answer is 721 grams of carbon dioxide.
The limiting reagent, also known as the limiting reactant or the limiting agent, in chemical reaction is the substance that is totally consumed when the chemical reaction is complete. The amount of product formed is limited by this reagent since the reaction cannot continue without it. On the other hand, excess reagent is the reactant that is not used up when the chemical reaction is finished. The excess reagent remains because there is nothing with which it can react.
To further understand the concept of limiting and excess reagent, let's go to the lab and solve some problems. Let's go! If 6.60 moles of H2 are made to react with 4.42 moles of N2, what is the limiting reagent? How many moles of NH3 will be produced? And what reagent is in excess and by how much? The first thing we need to do here is to check if the equation is already balanced and all of the given information are converted into moles. If it is already done or given, we can proceed in calculating the mole ratio of the equation and multiplying it to the given information. If all of 6.60 moles of H2 were to be used, the equation will be 6.60 moles of H2 times the ratio of 2 moles of NH3 per 3 moles of H2. This would give us an answer of 4.40 moles of NH3.
Meanwhile, if all of 4.42 moles of N2 were to be used, the equation will be 4.42 moles of N2 times the ratio of 2 moles of NH3 per 1 mole of N2, which would give us an answer of 8.84 moles of NH3. Now, we can determine that the limiting reagent is H2 because it produces the smaller amount of product, while the excess reagent is N2, which produces the larger amount. In calculating how much is left in excess, we will need 6.60 moles of H2 times the ratio of 1 mole of N2 per 3 moles of H2, which results in 2.20 moles of N2. Then, to get the excess amount of N2, we subtract 2.20 moles from 4.42 moles, which would give 2.22 moles.
The theoretical yield is the maximum amount of product that will result if the limiting reagent is completely consumed. It is the amount of product predicted by stoichiometry. The actual yield is the quantity of the desired product actually formed. On the other hand, we can also calculate the percent yield. The percent yield is the ratio of actual yield to the theoretical yield expressed in percent form. It is calculated as percent yield is equal to actual yield over theoretical yield multiplied by 100.
Now, we will show you a problem regarding on how to get the percent yield. Now let's go somewhere where we can solve it. So the given problem is, suppose 54 grams of ammonia were produced from the reaction, then the actual yield is 54 grams, and the theoretical yield is 78 grams, and the percent yield is blank. So using its formula, we can get the percent yield by dividing the actual yield, which is 54 grams, by the theoretical yield, which is 78 grams, and multiply it by 100 to get its percent. Now we get an answer of 69.2%.